All right, let's start with quantities, page 49. Earthworks. Earthworks form a major part of most civil engineering contracts. The pricing of this work is made difficult by its relatively uncertain nature and extent and the effect of weather and water. So, quite a number of factors affect earthworks, as you can see. SANS 1200 recognizes these factors and permits the tender to make allowances for them. And these are the allowances that start impacting on our calculations. The basic principles of measurement and payment for all earthworks are that the rates tendered for excavation shall cover the cost of excavating and reuse of the excavated material in backfilling, forming embankments, terraces, etc., and the cost of disposal of any surplus and unsuitable material within the freehold distance. Now, that's a new concept, right? What is that concept? Freehold. Basically, SANS 1200 says that if you are excavating in that area, freehold is 500 meters that the client doesn't have to pay the contractor to move the material to that point. So the first 500 meters is free to the client. So if we're saying that the whole distance of all this excavated material to dispose of is 2.5 kilometers, then how much in terms of distance will the client pay? 2.5 minus 0.5 kilometers, and he'll only pay for 2 kilometers of transport per load or whatever the arrangement is. All right, so that's what freehold distance is. The first 500 meters or half a kilometer, same thing, is free to the client. The untrimmed earthworks or bulk excavation is finished to level have been completed before the commencement of restricted area excavations. Excavations that are required to be backfill will be measured as if taken out with vertical sides, regardless of whether they've been taken out with sloping sides. They will be measured from the net plan of the finished concrete footing, foundation, building, or concrete structure. What are they saying here? What are they saying here? This is what they say. They're saying this. If we need to dig a trench to put in a foundation and to put in brickwork, right? If we dig a trench, the calculation for the volume of earth excavated is only this. If you as a contractor decide to do this, and you decide to do this because the earth is not cohesive enough to stand up on its own. Let's say it was sandy and it caved in every time you dug. And at this angle, you found that, you know what, I can still put in my foundation. I can still thereafter dig my, put up my walls. The client is not going to pay for this. Notice the added volume and area of that excavation versus that one. So that's what that line means. The client only pays for this type of excavation, not that angle that you chose to make your job easier. All right. Computation of quantities. Earthworks will be measured by volume once only, either in compacted embankments or in excavations. Measurements will be to finished shapes, sections, and profiles as shown on drawings or ordered. No excavation or embankment formed outside the specific lines and levels will be included in the measurements unless such extra work has been ordered on the written instruction of the engineer. Except where earthworks are carried out to simple geometric shapes, the volumes of material handled will be computed from cross sections at suitable intervals by the method of average end areas or any other method that you feel is easier. Should you wish to check the engineer's quantities, the contractor may at his own expense take levels and prepare the cross sections necessary for the measurement and computation of quantities. If you believe that the engineer measured incorrectly, then you can redo the calculations to prove him wrong. All right, you're required to refer to SANS 1200 for the complete list. Now, we're not going to go through the complete list because SANS 1200 is this thick. I will show you, and I will provide in your data sheets the relevant SANS 1200 documents for you to use and show me that you know how to use it when you answer your test or your exam. All right, clear and strip. The unit of measurement is square meters. Now, when we talk clear and strip, what are we talking about? We're talking about an area that we are going to build something. And when you get there, there could be a fence line, there could be an old building there, there could be a big tree there, right? Now, this is what clear and strip is. You need to clear all that away. So in terms of quantities, your area will be what you're clearing and stripping. And if this is 10 meters and this is 5 meters, then how much are you clearing and stripping? You're clearing 10 times 5 is equal to 50 meters square. Right, so that's what clear and strip is. Or the other word is clear and grub. Clear and grub. All right, remove topsoil to a normal depth of 150 millimeters. Now we're saying once we've cleared and stripped, we need to remove topsoil. Why do we need to remove topsoil? Because within that area of the topsoil, you've got a whole lot of activity that's happening there. You've got creatures living, you've got roots and vegetation, you've got little boulders. You need to start on a clean, flat surface. So SANS 1200 is saying, remove the first 150 millimeters of topsoil. Stockpile and maintain, keep it on site. The unit of measurement is square meters. Where removal to greater depth is ordered, the area measured for payment will be increased pro rata to the average increase in depth. It is commonplace to find that the quantities of site clearance and topsoil removal are the same. No, I don't like that. Because if that was our area of clear and grub, let's put some numbers to the topsoil. 50 meters squared times 0.15 gives me how much? 50 times 0.15. 7.5 meter cube of material. What do you do with that? Keep it in one corner for what? For later? And when you're done, leave it there and quietly leave the site? No. This is a truckload. There's a cost attached to that. And when we have a volume, we can get a cost of removal. But if you have an area, now what do you do with that? Yes, we cut the grass and clear up for that area. We can quantify that. Now you got an area of topsoil? No, that doesn't fly with me. Reduce it to a volume, and we can work with that in terms of a costing to remove. All right, so for now, clear and grab area, remove topsoil is a volume. We'll see that in a calculation as we progress. All right, bulk excavation. Separate items will be scheduled for each type of excavation or its structure and for each class or manner of disposal of excavated material. Extra over items, new concept, will be scheduled for intermediate excavation, hard rock excavation, and boulder excavation. The quantities calculated for the extra over items are included in the item excavating all materials, and the unit of measurement is meter cube. All right, new concept, extra over. I believe to understand the concept of extra over, we'll have to do an example, right, for you to see how it is handled in terms of physically rather than a definition. So we'll come to that. A restricted excavation is one so restricted in area or width as to preclude the removal of material by a bulldozer. Separate items will be scheduled for separate structures. And in the case of pipe trenches, to different depths in 1 meter increments. All restricted excavations will be measured by volume. The volume of short pipe trenches will be computed from the minimum base width of the trench. Extra over items will be scheduled for different types of materials: hard rock, intermediate, shale, clay, and sand. Right, the quantities calculated for the extra over items are included in the item excavated or excavate for restricted foundations, footings, and pipe trenches in all materials. And the unit of measurement is also cubic meters. All right, extra excavation in all materials to provide for working space around the structure. What we say, if this is your house, we need area to work in. All right, the area will be computed from the perimeter of the structure and the average depth of excavation on the perimeter of the structure. The unit of measurement is square meter. Wherever possible, simplify the shape for measurement and use geometric formula to assess volume. When this is not feasible, use approximate methods, such as those listed below. Now, there's that one type, there's another type, there's another type, there's another type, and there's another type. We will not be doing this, or this. We will be doing that one, because it's the easiest one. All right, the first three are common for roads and railways. We are not only doing roads and railways, right? While the last two are common for bulk earthworks. And you can see or read up what an average end formula is. Prismoidal formula, arithmetic is bulkier, so there's a lot more arithmetic there. Simpson's rule is a lot more accurate, right? And there must be an odd number of cross-sectional areas, an even number of lengths. Let's look at average or grid average method. This method is used primarily for bulk earthworks. The whole area to be measured is divided into a suitable grid. The values of the original and final ground levels are known at a representative point on each grid section. The volume of each section is a product of its plan and the difference in its levels. The most convenient method of dealing with the varying factors is to weigh the sections according to their relative area. Now, this won't make sense to you at all until we do a calculation. All right, so let's look at a calculation. Now let's look at question 1 on page 55. Let's look at this one. Let's try and understand this first, right? We've got a grid, as you can see. We've got some points and some numbers. Now, these numbers that you're seeing are numbers generated by, sometimes, in most cases, yourself as a young graduate engineer. Go to this area and get me some spot levels. What do you use to get a spot level? Use a dumpy level and a star. All right. Before we go any further, just to refresh your surveying memory, if you have an area that you are going to, all right, and let's say you set up your staff here, and there's the dumpy level. Now, the dumpy level just looks straight, isn't it? So if you place your staff here at a high point, what are you going to see? You're going to see a low number, isn't it? If you place your staff here at a low point, what do you see? You see a high number. Okay, so what does it tell you? As the numbers fluctuate, you get an idea of how the land fluctuates. Okay, so low numbers mean it's a high point, high numbers mean it's a low point. All right, so let's go back to this. What's happening here? Lowish, high point, a little more higher. What does that mean? It's a lower portion of the ground. All right, that one, what's going down? More low or more high. Right, so that's basically how to understand what's going on. We've got this particular sketch and we get numbers. Now, these are the numbers that you are seeing here that tell us what's happening with this area, how it is undulating. All right, now, if these are all the spot levels, what is our starting point? Where do we start? Start there, start there, start there, start there. Which one is it? We need to find an average. That's why this method is called the grid average method. So we got a grid, we're going to find the average. And let's do that particular example. How do we find the average of our spot levels? So all right, let's look at this. Let's say corner sections. Yeah, all right. So let's look at this. Corner sections apply a weight factor of 1. What's a corner? If you say A1 is a corner, D1 is a corner, A4 is a corner, D4 is also a corner. All right, so let's apply a factor of 1. All right, so let's see. All right, now we've accommodated for all the corners. Now let's look at the next thing. Edge sections. Apply a weight factor of 2. So what's an edge? All right, what's an edge? Would you say B1's an edge, C1's an edge, D2 is an edge, D3 is an edge, and you've got C4 is an edge, B4 is an edge, you get A3 is an edge, and A2 is an edge. All right, so let's put that down. All right, so we took care of all the tubes. All right, we took care of the tubes. Now let's go back to the maps. All right. Internal sections. Apply a weight factor of 4. So what's internal? If you say these are our internals, those are internals. So let's apply a weight factor of 4. 4 times, that's 120. First one, 480, 4 times 30, 20, 4 times 90, 20, 40, 60. And the last one, 4 times 35 is equal to 140. All right, so time to do a check. Have you accommodated for all the numbers that are there? All right, you need to do this, or you will get lost. All right, now let's complete it to find the average of this. Tally all that up and you get 36. Tally all that up, you should get 2605. Right? And 2605 over 36 gives me 72.361 meters. And that is our average level. Okay. All right, question 2, same method. Same method. This time we went one step further. Right. Remember I said we do baby steps, we crawl before we start to run. Now I've taken that and I've put in a dimension here. I put in a dimension of 5 meters, 5 meters. If we know it's 5 meters square, then don't we know what this entire area is? Know what the entire area is? 30 times 40, 1,200 meters square. So we have an area. And we're saying within that area, we have a structure. So the structure is sitting in this area and we have spot level. So it needs to be cleared and reduced to a specific, or not specific, reduced to a common level. Now, I want you to use the method that we just did, all right, to find for me